Asteroid Day. So it's great that we can all be here together at the Kennedy Space Center. What better place to celebrate science and space exploration and the science of asteroids and protecting the Earth from asteroids than at the rocket place. The science that goes on here, the science probes that have been launched from here are really, this is the place where we're going to save Earth, actually. If we ever have to launch a mission to deflect an asteroid, it's probably going to be from the Kennedy Space Center. So it's a great place to talk about International Asteroid Day. June 30th every year, and it's on June 30th because that's the anniversary of the big 1908 asteroid impact that occurred over in Siberia, which I'll tell you about in just a few minutes. It's called Tunguska. Every year on June 30th, we celebrate Asteroid Day to educate ourselves about the hazard from asteroids and comets, what we can do about them as human beings. So I'm going to give you a short talk about Asteroid Day and how it got founded, but more importantly, the hazard from asteroids and comets that threatens us as human beings, and then what we can do about them here in the future. So, asteroids and comets, what are they? They are the leftovers from the early solar system. When the sun and the planets formed 4.6 billion years ago, stuff that didn't get formed into those planets was left over, and they formed the asteroids and comets. They're debris, they're leftovers from the planetary formation 4.5 billion years ago. And then there are two kinds of debris, asteroids and comets. Asteroids formed in the inner part of the solar system. They're rocky bodies. They've been through some high temperatures typically, which melted away any ices and got rid of any gas around them, so they're hard, rocky bodies. Comets, on the other hand, reside out in the outer reaches of the solar system, and because it's so cold out there, far from the sun, they retain ice and gas. When it vaporizes close to the sun, they form a beautiful comet tail, and that's why we love comets, except when they're headed towards the Earth. So asteroids and comets are both kinds of leftovers from the early solar system. Now in the inner part of the solar system, you've got the planetary orbits that you can see here, Earth, Mars, Venus, Mercury. The green dots are asteroids in the big asteroid belt between Mars and Jupiter. That's where over 1 million of them have been cataloged today. That's where most of them stay, but a bunch of them get pumped into the inner solar system by collisions with each other, like billiard balls. And also, more importantly, Jupiter's very strong gravity sends a lot of these green asteroids into the red zone, where we have what are called near-Earth asteroids and comets that penetrate the inner solar system and fly around in their orbits around the sun, and of course, sometimes a planet sweeps up one of them. In other words, it collides with the planet. And in this case, ours is the one we're worried about. So all these red and yellow dots are near-Earth objects that have been cataloged, and they can collide with the Earth over time. Now, how big are these objects in the inner solar system? The biggest one is this one, Eros, visited by a NASA spaceship back in 2000, and it's about the size of Orlando. And that's the biggest one in the inner solar system. It's not headed towards us at all. But there are lots of little ones, many more little ones that are smaller. This one's about 1/3 of a mile across, called Itokawa, visited by a Japanese spacecraft back in 2005. And there are about 1 million of these babies running around the inner solar system that present a hazard to Earth. Here's a picture of that Itokawa asteroid visited by the Japanese spacecraft Hayabusa. And it's a rocky body that's assembled out of lots of boulders and dust that's been flying around for 4.5 billion years old. It's a leftover. It has been largely unchanged since the formation of the solar system. There you see Itokawa in the upper left. Small pieces of these bodies fly into the Earth's atmosphere and burn up every day. You've seen a shooting star at night, looking up into the starry skies. That's a piece of an asteroid or comet that's flying into the atmosphere. It's vaporized at that high speed when it comes in and runs into the air molecules up there, as you see in this video here. About 100 tons of this stuff from asteroids and comets falls on the Earth every day. Now, this flash in the sky is something we call a meteor. If it's a rock flying through space before it hits the Earth or any place else, it's just zooming through space, piece of an asteroid, that rock flying through space is called a meteoroid. If we see the flash in the sky as it burns up, it's a meteor. And if it lands on the ground and you can pick it up, it's called a meteorite. Right. And what do we call something that lands not on the Earth but on your head? It's called very bad luck. Hardly ever happens. In fact, there's no documented case in human history of anybody ever being killed by a piece of an asteroid or comet. But that's what we're worried about today, is the future of this stuff raining out in the sky. Here's an Arizona asteroid strike back in 2016. That's what I would say too if I saw a fireball in the sky like that. So these fireballs are very bright, maybe something the size of a basketball coming in, burning up in the sky, and creates that fireball that you see lighting up the landscape in these security cameras. I've never seen one. Most of us are asleep at night, or it's cloudy and we don't see these fireballs, but they do occur rather frequently. About 100 tons of dust grains and bodies like that occur daily, falling into the Earth's atmosphere. That's the smoke trail left by that one in Arizona. So the flash of light, the meteor, and then fragments on the ground, we can pick those up, and they're called meteorites. Astronauts on the space station, where I've been, have looked down in the atmosphere, and occasionally you'll see a shooting star burning up below you as it streaks into the atmosphere. They typically burn up 50 to 80 miles high in the atmosphere. So it reminds you of all the debris that's whizzing around up there, some man-made space junk plus pieces of asteroids and comets. Now, occasionally we have big chunks of asteroids and comets that land on Earth, and that's the hazard that we get from asteroids and comets. And I like this little phrase from history: you may not be interested in asteroids, but they are interested in you. And over time, over geologic time on the Earth, we've been bombarded by big chunks of cosmic debris. An asteroid about 50 meters across landed in Arizona 50,000 years ago and blew this crater in the desert, Meteor crater. That was about a 20 megaton explosion when that occurred 50,000 years ago. If that were to land in the middle of Orlando or another big city today, that would be the end of that city. And so we have to pay attention to what's going on in our solar system if we're to survive. You know, you can go to Meteor Crater in northern Arizona. It's a beautiful spot, a really interesting piece of history, the freshest large impact crater on planet Earth today. But they're all over the world. There are about 190 asteroid craters or comet craters on the Earth that have been found so far. And you can see they occur on all the continents and on the seafloor as well. So we know, like the moon, we have been struck many times by asteroids. And this is a Hollywood version of an asteroid strike, the movie Deep Impact from 1999, but it's pretty accurate. What happens is this body comes whizzing in at 50,000 miles an hour. It might be a mile across or half a mile across, a third of a mile across, and with that great velocity, it converts that energy of motion into heat and light. Kinetic energy being turned into blast energy. And so wherever this thing lands, it's going to dig out a crater if it's big enough, and then the shock wave will spread out. If it lands in the ocean, you're going to get a giant tsunami that can inundate the coastlines. Like this would be bad news right here. And so Hollywood got it right in terms of the general physics of impact. So the heat, the blast wave, and all the debris falling back into the atmosphere from that asteroid strike can do in people near the impact zone, and of course for hundreds or thousands of miles away if it creates a tsunami like that. So you get the idea. Really bad impact occurred 66 million years ago in the Yucatan Peninsula of Mexico. And this crater was found by gravity and magnetic surveys. It's called Chicxulub. And this is the asteroid impact that wiped out the dinosaurs 66 million years ago. And this crater is now buried beneath limestone sediments. It's only underground that we've detected it through our searches for oil and gas in the area. But this caused a mass extinction. 70% of the species on the planet, including the dinosaurs, went extinct. Here's a simulation of that asteroid impact 66 million years ago from a supercomputer. And you can see the crater being formed, the debris spreading out for hundreds of miles on either side. And if it occurs in the ocean, as this one did, you get a massive wave spreading out in all directions. So no one's ever seen one in human history. We've not witnessed this event. So we think that this really, it's out of our experience. Why should we worry about it? But this will happen again. We will be struck by a big chunk of cosmic debris. And unless we do something about it, we human beings, will go the way of the dinosaurs. Now, a reminder of that fact occurred back in 2013 over Russia, when an asteroid only about 20 meters across, 60 feet, about the size of this room, came into the atmosphere over Russia. And that asteroid struck at a shallow angle over the city of Chelyabinsk, and the explosion in the atmosphere did not reach the ground, did not create a crater, but some pieces reached the ground, and the blast wave hit the city a couple of minutes later. This is what the Russian drivers saw that morning on their drive to work. Came in at about weighing about 12,000 tons at about 30,000 miles per hour. And when it broke up and exploded in the atmosphere, the shock wave reached the ground in Chelyabinsk a couple of minutes later, brighter than the sun. And it struck the ground at blast wave and knocked in buildings and windows and buildings, doors. It blew in a roof on this factory in Chelyabinsk. About 1,000 people got sent to the hospital for flying glass injuries and debris that struck them. Nobody died, fortunately, but it's a reminder that if an impact occurs in the wrong place, at the wrong time on Earth, we can have some fatalities from this. This is a very dramatic statement of the power of nature, the power of this kind of a natural disaster, an asteroid impact. Here's how big Chelyabinsk was compared to a football field. Later that same evening, just by coincidence, astronomers had detected this asteroid, DA14, some months before, and knew that it was going to miss the Earth by only 18,000 miles. And so if that asteroid had struck the Earth instead of missing us, that explosion would have leveled an area the size of a metropolitan area, a big city. Fortunately, that one missed us, but it's the ones that we haven't detected yet, that we don't know about, that we're worried about today. And so our imperative is to find these objects before they can strike us. Nobody knew about Chelyabinsk before it hit the atmosphere. But if we do our searches on the ground and in space using telescopes, we can predict one of these asteroids, when one of these asteroids will strike the Earth. Back in 1908, on June 30th, Asteroid Day, one struck Siberia over Tunguska. This object was about 40 meters across, maybe double the size of this room, and it leveled 800 square miles of forest, an area big enough to wipe out a large city. And so this is the kind of event that occurs every 500 or 1,000 years, which we worry about causing havoc somewhere in a populated area of our planet. These are fireball reports mapped on the Earth by Air Force satellites, looking down at our planet for missile launches, for example. And those sensitive infrared detectors have found these asteroid strikes over the Earth from 1988 till 2017. You can see our globe is being peppered by asteroid fireballs and larger ones like the big red dot that is Chelyabinsk back in 2013. So it's a global problem that we face as human beings. Now, just to give you a summary of what I've said so far, there are a few big ones in the inner solar system, a lot of small asteroids. About a million of them could wipe out a city. And we only know about 1 or 1.5% of those objects so far. There are about 1,000 asteroids big enough to end human civilization if they struck our planet, but fortunately NASA's search program has discovered about 95% of those. None of them are headed towards us in the next few centuries. And how often do these impacts occur? Well, Chelyabinsk, about every 30 to 40 years, that flash over that Russian city. Tunguska, every 1,000 years or so. And then bigger events, 10,000 or 100,000 years apart, like destroying several states at once, that would be every 100,000 years. And you can see mass extinctions every 100 million years. So none of us have seen this happen. Nobody in history has seen this happen. But I can guarantee you, the Earth will be struck again by a big object. We should do something about it now that we have the skills to do so. Your chances of dying in a natural disaster like a flood or a tornado or an earthquake or an airplane crash are a lot larger than dying in an asteroid catastrophe. In fact, your odds of dying in one of those is only about 1 in 700,000 over your lifetime. Oh, by the way, what is your lifetime chances of dying? 100%. But you don't want to go in because of an asteroid strike. Fortunately, that's a very low probability event for an individual. But 7 billion of us on a planet for a few thousand years, likelihood's pretty high that asteroids will play a role in doing it to human beings. Now, do we need Bruce Willis to go out there and stop this hazard from occurring? Fortunately not. It's a lot simpler than that. If we just find the asteroids before they hit the Earth, then we can do something about them. This is the current count of asteroids found by the Worldwide Search Program, mostly funded by NASA. About 16,000 asteroids found so far. The big ones are red, the ones that can do in civilization, but we've got those mostly taken care of. Medium-sized ones, we're still looking for the majority of those out there, and we're starting to find a lot of smaller ones. But as I mentioned, this 16,000 is only about 1.5% of all the ones that could destroy a city on Earth. So we need to search. We use ground-based telescopes that are largely, again, funded by NASA, about $50 million a year. And they're coming online with better and better telescopes so that in the next 10 years we'll have hundreds of thousands of asteroids in the catalog. That's good news. But it still occurs at a far too slow a detection rate. And so a better place to search for asteroids than the night side of Earth, looking out at this white sector of space, is to launch a spacecraft with a telescope on it that can scan all of this orange area in the solar system. And we'll find the asteroids a lot faster by launching a small telescope to do this search job. So far, NASA has not been given the funds to do this, although they've proposed a mission called NEOCAM to do just that. If we launch this spacecraft, it could find all the dangerous asteroids in about 10 years. But if we have to wait for just ground-based telescopes to work on it, it could be 30 or 40 years before that job is done. And we don't know what's coming at us. So I think that's a very valid thing that we should do. If we have a warning, we can use several technologies to ward off an asteroid. One's called a gravity tractor. You park your spacecraft next to the asteroid and hover there, and the very weak gravity between the two bodies will tug on that asteroid and make it move off its orbit that might be colliding with the Earth. So all of us are attracted to each other by gravity, right? We all have mass, and so there's gravitational attraction between us, right? What's your name, ma'am? Stacy, do you feel the physical attraction between us right now? That same minuscule effect would help us divert an asteroid using the gravity tractor, if you have months or years of warning to work on it that way. Another technique, this is the gravity tractor hovering over the asteroid, and you can see pulling that big object towards that small spacecraft. Another technique is to fire a cosmic bullet into the asteroid. We did this with a comet probe called Deep Impact back in 2005. You smack the object with a high-speed spacecraft, and that can nudge it from its orbit and make it miss its appointment with Earth. And here's a demonstration of the spacecraft slamming into an asteroid. It's called Kinetic Impact. The transfer of momentum changes that asteroid's speed, slows it down, speeds it up, makes it miss Earth. And finally, you can use some exotic techniques like ion beam deflection or lasers to make a little puff of gas appear on the asteroid surface, and that's like a little rocket motor that can change its course over time. And finally, there's the Hollywood crowd pleaser. If you have to stop a big asteroid in a hurry, you might use nuclear explosives. But fortunately, even though we know how to do this, only in 1 or 2% of the asteroids that would strike us over thousands of years would we ever have to use a nuclear explosive. But it's there in our back pocket if we had to do that. The point is we have to practice this together. We have to use these techniques together. It's a global problem, and that calls for global solutions. So we might discover an asteroid that's going to strike somewhere on a line like this across southern Asia, but we don't know precisely where. And we've got to have all these countries, from Vietnam to Thailand to Burma to India to Pakistan. They've all got to cooperate on warding off a possible impact over their territory. And that's a geopolitical decision. You don't want it to land on Earth. You want it to miss Earth on this side of the planet or over here. But if you send your spacecraft out there and you move the aim point from here in the North Atlantic over Canada and the US, we might get upset about that. If you drag the aim point over France and Germany and Russia, they might get upset about it too. So we'll have to cooperate on a plan working together to divert an asteroid. And that's where Asteroid Day comes in. Asteroidday.org is the website. I've spoken about this at the United Nations with my friend, cosmonaut Doran Pranariu, and the Association of Space Explorers was the outfit, our Cosmonaut and Astronaut Club, if you will, this professional society that submitted the resolution to the UN to recognize Asteroid Day. And the United Nations is the place where a lot of discussions are occurring today about how to divert a dangerous asteroid in the future. And I won't go into this, but there is a process in place today based on some of our suggestions from the space flyers about how to use the UN to come up with a plan to divert an asteroid that might be coming towards us. Now, NASA has a Planetary Defense Coordination Office. These are a couple of the guys who run it. There is an office at NASA that deals with planetary defense. They have a plan that has been approved by the government, and that plan is a strategy that I'll show you right here. You can look this up online. The Near-Earth Object Preparedness Strategy. But there's no money to put most of the measures into place, but at least there's an outline of how we would deal with a future asteroid impact. One of the most important things we can do, aside from that telescope I mentioned, is to demonstrate how to deflect an asteroid. And so there is a joint mission proposed by the Europeans and NASA to slam a spacecraft from the US into a small asteroid, a harmless one, divert it from its orbit, and then a European spacecraft would monitor the results of that collision and prove that technique. That's called AIDA. Both NASA and ESA, European Space Agency, lack the funds to do this. We can all call up our congressmen and tell them to fund this kind of a mission, because it's a way to demonstrate that we know how to do the job against a future asteroid impact. So I'll wrap up just by saying that we're driving around the solar system today without insurance. We could do a lot more with our space skills and our warning systems to develop the capability to divert an asteroid. Today, we would most likely be struck with no warning by a small object, like a Chelyabinsk. We have tracking and warning capabilities. We have spaceflight technology that we can put together to divert a dangerous asteroid. But we have to have that determination, that human will to act. And that's what we have to do collectively as a global civilization. And so, as we said in one of my organization's reports, the ASC's report, we're no longer passive victims of the impact process. We can actually change the way the solar system operates and save the human race in the future. So that's my intro to Asteroid Day. I hope that we'll have the will to do something about it, and come talk to me in detail about this at 3 o'clock. I have about 3 or 4 minutes for questions. So if you've got any, let's get the microphone up there. Where's Livia with the microphone?
Right here?
Yeah, if you've got a question, come towards her. I'll be glad to answer some, and then I'll introduce Humberto.
Individual questions.
Yes.
So raise your hand. I'll come to you. If you ask a question, I'm going to have to sing and dance, and I'm horrible at singing and dancing. This young lady has been here since very early. I'm sure you have a question, right?
Well, he basically answered a lot of my questions.
Oh, good.
So, you did very well. Not really, actually. I did, but not anymore.
All right. All right, right here. And then I'll go.
Good afternoon. My name is Joseph from Kentucky. My question is regarding the what you said earlier about the gravity of Jupiter pushing asteroids towards Earth. Can you please explain how come gravity repel an object?
Oh, okay, that's a great question. Yeah, because usually gravity we think of as pulling things towards us, and that's certainly what Jupiter's gravity does. But as Jupiter moves around in its orbit around the Sun, it tugs on all the asteroids that are around it, okay, and it modifies their orbits. And so instead of going in a nice circle around the Sun at a nice steady distance, that tug from Jupiter's gravity can make it go farther from the Sun and then loop into the inner solar system. And that changing of the orbit, making it more oval than round, that changing of the orbit from Jupiter's gravity sends a lot of asteroids into the inner solar system. Most asteroids will live in the inner solar system for about 10 million years before they run into a planet and explode. Or they fall into the Sun and they get destroyed, or they get sent clean out of the solar system by a near miss at a planet. So then Jupiter is continually sending new material into the inner solar system from the asteroid belt. And comets come from way out by Uranus, the Kuiper belt out there beyond Pluto, and the Oort cloud even beyond that. So, does that answer your question? It just modifies the orbit so that they swing in closer to the Sun.
Right over here.
Yes.
Hi, I'm Andy from San Diego.
Oh, hi, Andy.
So when you say that you have found only 1 or 1.5% of the asteroids and 95% of the major ones,
yeah.
How do you go about estimating how many you haven't found when, of course, you haven't found them yet?
Okay, so that's a statistical problem. Okay, how do we know what the total number of asteroids is if we haven't found them yet, right? And so what they do is they survey the night sky, astronomers survey the night sky with telescopes looking for asteroids. And they'll find new ones and catalog those, but sometimes they'll find the ones they found last year or 6 months ago. And depending on how fast they pick up the repeat asteroids, how fast do they come back into the telescope's view, we begin to estimate how many are known and how many are unknown. It's a statistical estimation problem. We also have estimates on the total population from the number of fireballs that appear in the sky, the number of meteors that are detected with radar, for example, and counting craters on the Moon and the other planets helps us estimate the total number of asteroids that are out there today. So it's a statistical problem, and Humberto can probably explain it much more than I can.
All right, so we're going to take one last question here.
When you were in space, did it feel as long as it did on Earth?
Did time feel the same while I was in space?
Yes.
Well, I guess the answer is yes. There is an effect that Einstein discovered with his theory of general relativity that says the faster you go, the slower time will appear to occur to you, right? You've heard of that. So I went around the Earth at 17,500 miles per hour for a total of about 53 days on my 4 trips. And I've calculated how much time slowed down for me. It was about 3,000ths of 1 second. That's how much time I saved by flying around the planet for those 53 days. So, don't I look a lot younger? Okay. Great question, and you can read about the answer to that question and a lot of others in my book called Ask the Astronaut as well. It'll be upstairs in the space shop. So now it's time to introduce my partner, Humberto. Humberto Campins is an asteroid expert, scientist, PhD. He and I studied asteroids together.